Okay, so first thing I wanted to talk about today was just kind of a roadmap, a little bit of where we're going to go today. So we got a lot of time, as usual, so we hope to cover a lot of things. I want to talk about reviewing a little bit of some things we learned about the introduction drafts that we talked about. Also get you on track for, I believe, this upcoming Wednesday to get draft your methods in. Is that what you guys follow on syllabus? Okay, so before class on Wednesday, if you'd like to have feedback on your draft of a method section, please have that prepared and sent to the course TA, Lindsay. So last time we did it for after class or by the end of Wednesday. Today this week we're going to be a little bit more on point and have it before class. That way, if we have time in class, we can work with you individually and work through it a little bit. Okay, so if you'd like to have that, hopefully you guys have been working on that since you got the last one in last week on Wednesday, since that's been on the syllabus, so there should be no surprises there, and you can have that ready if you'd like some feedback. We'd be happy to let you provide it. Okay? So we'll talk a little bit about method section and how to go about that. We will get deeper into some data analysis. Okay, some procedures, the methods that we use but to work with our neurophysiological data. So we'll work into that because what's happening next week on Wednesday? Yeah, there's a test on this upcoming, not this upcoming Wednesday, but next week. Okay, so that's not very far around the corner. So I want to make sure that we're really prepared for that. Really set up well to succeed. Okay, it's not going to be like normal tests that you've taken. As you might imagine, hopefully, and you know very clearly at this point, this is not like most classes you've taken probably either, right? So our tests are going to be a little bit different. You've got to be, it's going to be a test of a lot of different skill sets that we've been working on. So it's going to be a measurement and an assessment of if you know how to work with the data in the way that we've been practicing working with it. So it's going to require having some competency and familiarity with knowing how to work MATLAB for the processes that we do to process some data. Okay, so you're going to have to be practicing with that, just like I said at the end of last class. Practice with those procedures over the weekend and over the rest of that subsequent week. So it's going to test if you know how to work with the data. It's going to test if you understand the conceptual ideas of what we're doing with the data and why. It's going to test if you understand the conceptual ideas of our experiment. The conceptual ideas of both the cognitive and the neural models that we're working with memory. It's going to test if we have a good working understanding of APA format for the writing of proper scientific report that we've also been working. So we've been really busy. You guys have been doing really good, working really hard. We've been doing a lot of stuff, right? These long 5-hour classes twice a week, we put a lot of time in. And then you guys have put a lot of time in out of class. So we've actually covered a lot of stuff. I'm really impressed. He's done a really good job. We've actually done what we started off the first day of class aiming as our target, right? We said we have a tall order to fill in a short amount of time. We got to learn cognitive psychology, neurobiology models of memory. We need to learn experimental design. We need to learn APA format of how to communicate our experimental design. We need to learn what is MATLAB and how do we work with that computer system. We need to learn what is presentation. How do we learn with that stimuli delivery system. We need to learn how to actually work with EEG lab and ERP lab. What is physiological data? How do we analyze it? What does it mean? What are the limitations? We've done all of that, incredibly. So, it's going to cover all that. Another way to say that is it's going to cover, the test is just going to cover what we've gotten to so far. So, be prepared for that. Are there questions about this stuff so far? Okay, so we'll talk a little bit about that as we move through today's material. Let's see here what happens. We're also going to talk about developing our hypotheses a little bit further. Okay. We'll talk about some basic elements about the experimental data collection. How many of you guys are done with the data collection? Remember last week we said today was the day that it was supposed to be done. We've had this for a couple weeks now. So between your group of 2 people, we got to collect 10 people, 2 of which can be you guys, which means that really you're only accountable for 4 people, a person, to test and measure over the last 2 or 3 weeks. So I don't think that's a whole lot to be asking. I think that's pretty reasonable to be working with. So that needs to be done. If you're done with it, and you haven't uploaded your subjects' data folders to our appropriate class folder online, please do so at your earliest convenience, and that'll make it a lot easier for us to move on to the next stage of the project, which is analyzing that data and making sense of it. Okay? If you haven't collected those subjects, work with your partner and try to get that done in the next day or 2. It's going to be late, basically. It's not done yet by today. Lucky, did you have a question? You had your hand up earlier, a moment ago? Maybe not? Okay. Okay, so in terms of preparing for not just the exam, but of course the projects, preparing to be able to work autonomously, independently with the data, and write your reports, make your explorations and discoveries, and all that kind of good stuff. Hopefully you guys have been able to follow the lecture copies that I post to Blackboard. I don't post them every class, because what I do is I have one link that's always on Blackboard, and it goes to the playlist for the class lectures. And that'll be updated whenever there's new content that we have after the end of each class. So that's sort of on you to visit when you want to study or check in on what exactly was said or done during the lecture demonstrations. So how many of you guys have tried to take advantage of that resource? How you guys? Do you find it useful or not? Is it helpful? Okay. So what I'll ask is actually a request. If any of you guys find yourself using that resource and watching some of the lecture videos, I'll ask a favor, if you don't mind, which is if while you're watching it, you notice that there's a section that's really useful for you, or there's a section that you want to go find during the lecture, and then you find it, because they're long, But if there's stuff where you're like, oh, this is actually really good, write down what's happening. Just like a topic wise. Okay, this is discussion of how to make a good hypothesis or something like that. And if you can log, just on your note or whatever, the timestamp on the video. So at 37 minutes and 22 seconds in, had a really good discussion about item and source memory and how that plays into our paradigm, or whatever that is. Keep a little log of that and shoot it over to me on email. And what I can do for all you guys then is YouTube allows this nice little feature where I can copy what you write of your timestamp of exactly what happened at that time that you thought was good or useful that other people could benefit from, and I'll just paste that into the little, I guess it's the About section in the video that has a little description. And what it allows your classmates to do then is once I save that, you can go to that menu and the timestamp that you wrote becomes a hyperlink, which means if anybody wants to go to that point in the video, all they have to do is click on the number at the time, and it'll take them automatically there. So it's a little thing to help your peers out. Does that make sense? So if you do utilize that resource and you're finding it useful or helpful, if you don't mind helping out with that favor, then it'll help everyone to succeed just that little bit more. Sound like a pretty good deal? Awesome. That'd be really great. Okay, so that was one of the things I wanted to talk about there. So hopefully everybody got their introduction sections provided back to them with some feedback. For the most part, people had a really good start. Not everybody was able to get them in. So if you haven't done that, please take advantage of this opportunity to get feedback on your sample drafts for your method section on Wednesday. It's a really good opportunity. You have 2 sets of eyeballs looking at it with different points of view. You have the course TA, Lindsay, as well as myself, and it's a really, really good way to save points from being lost on the actual submission of the paper. Okay? And so please take advantage of that for the method section. Did anybody have a chance to go through some of the feedback that we provided over the weekend, or have any questions about that? Yeah, Brittany?
I went through and the hypothesis. Do we need to, like, how much more in depth do we need to go? Like, I feel like I've scratched the surface, but like I feel like I'm at a stop, like I'm stuck, because more literature or.
That's a really good point. Really good question. So if anybody didn't hear what Brittany said, she was asking about, in regards to feedback about making the hypotheses a little bit more specific, a little bit more in depth for your introduction sections on your research papers. How much more in depth? What is actually constituted by that? What do we actually want when we're asking for that? Am I capturing your question right?
Yeah.
Okay, cool. So, let me see if I can walk through a couple specifics on how we can do that better. At least what I'm looking for, and I think what a lot of people would be looking for in reading scientific papers. So, and I hope that it's also what you would be looking for when you read these papers in the literature. When you're reading your background reading, I hope that it's also things that you're looking for that the author should be giving to you, right? Which is, can you please just tell me exactly what you were looking for? So I know to look for it to see if you found it, right? Okay, so let's see if we can talk about that a little bit. When we talk about an introduction, or our hypothesis, okay, so notice I made it plural because through the scope of our course, we're going to have plural. We're going to have several hypotheses that we develop. Right now, all you need is one. That's all you got to work with, right? We'll build. Because once you get this little fundamental structure down, it's not too hard to add on some extra stuff. So right now we can just work with one, but as we work with more data, we grow, we expand things, it won't be too more difficult to add some more. And so, let's see here. We want to know a couple things. Let's see. So, a couple things that we want our hypotheses to communicate to our readers, and they're basically the same pieces of information that we want our writers, who we are reading, to communicate to us, right? One and the same thing. We want to know, basically, what are the effects of interest, right? So, by an effect, you guys have all taken stats and research methods, right? So we know that when we talk about an effect, it's a loaded term. An effect in this regard is referring to basically a difference between conditions, right? Am I wrong? Everybody on board with the idea? Okay, so let's see if we can have some examples of that, okay? So an effect of interest could be, in this case, behaviorally, it could be memory accuracy. Okay, so that could be percent hits minus percent false alarms. Okay, so this is a behavioral effect. Okay, we could also talk about a physiological effect. Okay? What would be a physiological effect that we've talked a lot about in class? Yes?
When we were talking about like the familiarity and how it happens in about 400 milliseconds versus the recollection happens a little bit later.
It's a good start. What do we call those? Huh?
Like functional regions in the brain?
No, what do we name those?
Oh.
What are those effects names in particular?
Was it the
Familiarity.
300?
Not quite the P300. What? Close. Familiarity. What was an effect that we talked about corresponding with familiarity in your
FN400?
FN400. You guys remember that? Okay. So by the way, I was going to have a quiz this morning. That was going to be stuff that was on it. So heads up. That was stuff I was expecting that we should have been familiar with. So keep that in mind as you move forward in next classes and exam prep and all that kind of stuff. So, physiological effects. It could be the FN 400. It could also be the LPC. It could also be basically an implicit repetition effect. Repetition. There could be fluency effects. They could have been LPN effects, latent parietal negativity. All those things that we talked about a couple lectures ago in terms of different physiological effects. Remember we had all those different topographic maps on the head. We spent a lot of time on walk through every condition that you would contrast, the citations of literature that reviewed those effects, the time points, the locations on the head, all that good stuff. We have pictures of that on our drive folder of those lecture notes. Okay? You can review that on the YouTube clips if you need to revisit it. We had lots of different physiological effects that we could have. You can also have behavioral accuracy. Again, you can have reaction time. Reaction time, effects, etc. Okay? So, first thing in a hypothesis, we want to tell people what are the effects that we're interested in. Okay? And these are going to be those effects, which are contrasts between different conditions of interest. And there's some extra defining features that we need to include in our hypothesis in order to fully characterize what we're predicting about these effects. Because these effects, if I just say FN 400, as a reader, they're not going to know what that means necessarily. Right? We need to explain what that is. So we're going to break down some other elements of a good hypothesis that we're looking for, Brittany. Okay? So, if we start with the effects, of course, right? Another thing we might add, right, are of course the conditions of interest. So start with effects, but of course the effects are defined basically by the key conditions that we care about. So some of you guys developed hypotheses that focused about source memory. Other of you guys wrote hypotheses that focused about item confidence, 5s versus 4s, what have you. You're going to have really different conditions of interest. Some of you guys are going to write about conditions like source correct versus source incorrect. Other of you guys are writing about conditions that are being contrasted, high confidence recognition versus low confidence recognition. Okay, we need to be able to verbalize that, write that out in our hypothesis. So we need to say basically, what are we looking for in an effect, but what conditions are we going to contrast in order to capture our effect? Okay, so I'm just going to keep it simple here. Let's say you want to look at the FN 400 or the LPC. We might have, as an example, conditions of hits and correct rejections. Now, because we're using our item confidence memory paradigm, right? Now you have to add to your reader, you have to give them a little bit more piece of information about this hypothesis, don't you? You got to tell them, what the heck is a hit? Now, in this case, we're going to assume that your readers are scientific, and they might not need to be told that a hit means it's an accurate identification of an alignment. You could put that in if you want, but we're hoping that that's already solidified in their broad understanding of science at that level. You can put it in. What I'm talking about in defining what a hit is, we want to tell them what are we operationalizing a hit as in our experiment. So in this case, hits are going to be old items that were 4 responses and old items that were 5 responses. And we'll also say what constitutes correct rejection. So those are going to be new items that are 1 and new items that are given a 2-item response. Does that make sense? Still on board, Brittany? Is that part of the information you were looking for? Okay, so we're only halfway there. And this is all just part of developing a good hypothesis. Okay? Again, remember we talked about this a few weeks ago in our lecture we talked about I think we used the example of like Christopher Columbus like setting off from Spain, right? And the idea is that we want to have a roadmap. We want to know where are we going. What are we intending as our destination? What's our objective? And we need to know before we set sail, before we leave shore. We want to know this in our own mind. And when we write this stuff for introduction, it's just writing out basically our notes in our minds so that other people know what we did. Because we're just telling them a story of what did we do in our science project. Yes, guys?
So I just had a thought, because I was having a little bit of a hard time with my hypothesis, but kind of putting it out, to kind of help come up with a couple ideas.
Yeah.
Can we add that to our introduction and then like send it to your master's student to look over again, or do you want to? Just in case, like, just kind of be like if we're going in the right direction. Kind of thing.
Yeah, you can.
Okay.
You can. But I'm going to instruct the TA to put the priority of her time utilized on working on the method sections.
Oh yeah, no, I figured.
So it's not. I'm not going to tell her don't look at that. I'm just
Okay.
going to say if you get a pile of papers, prioritize the methods because that's what we're on now.
Oh yeah.
But you can. Of
Yeah.
course, yeah. Is that it?
Yeah, no. Like I said, it's just because I get really paranoid with writing like this.
Don't get paranoid. We good.
Cool.
And you can send it to me, of course, as well. So, okay, so we're walking this out. First of all, the most important thing for this, I think, the most useful, is just doing this for us. Screw the reader for now, right? Like, we need to know what the heck are we actually trying to find. So I find this really helpful when I'm designing papers or studies or whatever. I gotta write this stuff out for me. And if you talk to Lindsay, when she comes into, because we're working on projects in the lab and stuff, we're having these conversations all the time too. And I'm like, all right, let's just slow down. What exactly are we trying to find? And we write this out for ourselves. And then it's easy to communicate in the introduction for people because you just tell them what you had to sort out yourself. Make sense? So we need more information though to guide our journey, as well as the information communicating in the writing of the hypothesis for the paper. Okay, so we've got the conditions, we've got our effects. Now, what else do we need to do in explaining to people is if we're going to make a hypothesis about familiarity or recollection, okay, and we can also add, let me add a little broader thing here, okay, what are we actually interested in, right? You could even add a little bit about sort of the topic or issue, your hypothesis. So in this case, we'll say recollection or, familiarity. That's sort of the broader element of a hypothesis, right? I can kind of put that over there. Okay, so I'm going to call this point 0. If this is 1 and 2, we'll call this sort of the 0 starting point. Is that helpful? Okay. So we know that we're sort of departing with our ship to go sail the scientific ocean, right? Our broad continent that we're trying to find, it might be an issue we're trying to just learn about in the context of recollection, familiarity, operation, and memory. It doesn't have to be, but it's easier. I think people all seem to write about that. God bless you. And we know that one way that we're going to explore that is by looking, our hypothesis is that something's going to happen to a certain effect of interest that we have, whether it be behavioral or physiological, and we're going to look at these effects and identify them based on conditions that we're particularly interested in. Okay? That could be hits or correct rejections that could go on to lead to a FN400 measurement or an LPC measurement, right? Now remember, FN400 might be related to familiarity, LPC might be related to recollection. Okay? Now what we need to do though is answer some information. Right? We need to tell our readers, because they're looking to you as the experts of the biological signals of memory that they're trying to learn from in your writing. So you need to help educate them a little bit, or maybe if they're already experts, you help remind them a little bit. It's always really helpful, right? When somebody kind of like reminds us about what we already know and might have forgotten a little bit. Okay? So, okay, great. So you're going to look for effects of familiarity by contrasting hits and correct rejections to see if your experiment reveals an FN 400 effect that would suggest that subjects are using familiarity to make their judgments and their decisions about memory. Okay? If you're going to do that, you need to tell them, great, where am I going to look? So you need to show them, one, I'm going to say A, you got to tell them timing, and B, location. Okay? So, at least for physiology. Okay? So, you're going to have to say timing, you're going to have to tell them what is the time. So in this case it might be 400 to 600 milliseconds post-stim. Okay? Or if your hypothesis is about recollection, you might be looking 600 to 900 milliseconds post-stim. Okay? So, key information that your hypotheses have to have if you're going to work with the physiological data, at least with the ERPs, is you have to have a hypothesis about what's going to happen when and where. Okay? This is our information of what? What? Our effects and our condition of interest. What's going to happen when in our timing? And where in our location on the scale? Wouldn't you like to know that when you read a paper? And you're trying to figure out what are they looking for? You need to know that information as a reader, so we got to be cool with our readers and give that information to them too. Does that help a little bit, Brittany? Okay, so now we're carving out and developing a really good way of having our hypotheses, both for us to do good science, but also for us to be good authors and good writers, communicating our science. So we've got to basically include in our hypotheses our conditions of interest, our effects that we're seeking to explore and to identify and to reveal, the timing of those effects, when do we expect them to happen or predict them to happen, where on the scalp do we predict that there will be electrode sites that will be targeting to reveal these effects. Now you can have that in several ways. You might just say the posterior area of the scalp if you're looking for our implicit repetition effects, because we know those tends to happen broadly in the posterior area. If you're looking for the LPC, you might say the left parietal scalp regions, or you might also be very specific. You might say, we're going to look at the P3 electrode site. How you choose to handle that, whether it be by saying a single electrode, or maybe a group of 2 or 3 electrodes, or just a broad region of the scalp, is up to you based on how you think it's best suited to tell your readers what you're looking for. Or basically just how you want to guide your exploration of the data based on what you think is the most responsible way to assess your things. Okay. Let's add one more thing in here. Okay. What else could be something that we explore in the data that might be something of a hypothesis that you could have? Maybe a little bit later down the road. Yes?
Maybe your, your false alarms and your, I'm forgetting the term.
Misses?
Yeah, misses.
Okay, so false alarms and misses, yeah, but that would be included in these spots. This would be a condition of interest. Your condition of interest could be ERPs for misses or ERPs for false alarms or something. Yes, Lynn? Oh, okay, so that would be artifacts. I think that could be one of these topic or issues broadly, which would be maybe what's the role of including artifacts in data versus excluding them. You can see, do the effects of memory go away if you include a bunch of crap in the data? It could be a technical report on methodologies. You could actually show, do the data effects change based on if you're a good cleaner of the data or a bad cleaner, right? If you exclude too many trials, does that make the effects go away? Or if you include too many trials, including the blinks, including all the crap that we talked about, does that make the effects wash away? So I think that would fall under our hard thing here. But it's a good thing, absolutely, because you don't have to explore recollection familiarity directly. In that case, you could, but you'd be seeing how are those biological signals for them affected by a different issue, which in this case would be artifact correction sensitivity, or artifact rejection sensitivity criteria in signal detection framework, correct? So that's an idea. Something else I was thinking about, a couple of you guys emailed me earlier, a few weeks ago, about would the behavioral times change if you had left-handers? Or, later on, so you might look to see how these effects are changed or affected by neuropathology of the hippocampus. What if you have amnesia patients who've had damage to the hippocampus? So what I'm trying to refer to here is this idea of a third component that you would include in your hypothesis later, which might be group. Okay? Which is, you want to include in your hypothesis communication, or in communicating your hypothesis, how your hypothesized effects of interest based upon different conditions are going to be affected differently based upon different groups that you might include. Make sense? So not all of you guys have to include that, because some of you guys, in fact right now based on what you wrote, it seems like not a lot of you guys are yet very interested in exploring group differences. Yes, Ryan?
I just have a question.
Yeah.
I was thinking about expanding upon mine with like if how depression would affect the memory source. I'm really interested in that. Would that be a good thing to do?
It's a good hypothesis to have to ask how depression might affect the memory source.
Yeah, because like.
But I'm not, it's a good hypothesis, so there's nothing wrong with that. But we have to talk and think very carefully about how we would actually measure that. How are we going to measure depression? Because right now we don't have those measures in the data. Do you have an idea for it?
Yeah.
Okay, what do you got?
Well, we could use a depression test and find people who are clinically depressed and have them do the test and then compare them to people who aren't clinically depressed.
Yes, we could. That's exactly how you do it. You find people who were clinically identified as suffering clinical forms of depression under the presumably supervision of a clinician who was treating them, and then you would administer first exams to them to assess the degree of their depression, and then you would administer the memory test and see how those co-vary, right? What I would say is that you can definitely include that in this project, but I would say the way to include it would be in your discussion at the end of the paper when you discuss future applications of the work. Because I don't think we're going to be able to do that, particularly in the time that we have available, which is limited for this class. Two, you would have some ethical issues with the IRB that you just have to get through, which are not difficult. You just have to do the administrative sort of bureaucratic steps of going through IRB to actually work with clinical patients, which we're not approved for right now for this class. And so that would probably be a limitation to actually doing that here. But,
Closer to time.
I'm sorry?
I was gonna say closer to time.
Well, yeah, time is an issue. So when I asked how many of you guys have done with the collecting data, not even everybody raised their hands. And that was in normal people who don't have clinical forms of depression. So getting access to people to test is going to be difficult at a larger level. So I think that it's a good hypothesis to have, and it can definitely be integrated into your section in the discussion on implications and future steps to be taken. I think it's really good. It's a great way to set up a platform for our next study, but we're probably not going to be able to do it also. Okay, so you can include in your hypothesis how that might be affected by group. You could have it, that could be handedness group. That could be, hippocampal group. And love it. For your example, you could even basically create that separate group of an artifact. Or you could just replicate the same page, same subjects, processed in different ways. So these are things that you would have to include, right? So you have to tell them, what am I looking for? Where am I looking for it? When am I looking for it? And how do I expect it to vary if across different conditions or groups if we were to include them? Okay? And the very last thing that you want to think about including for your good hypothesis is going to be basically, what is your manipulation? What's your experimental? Okay, so you're basically telling your readers, what did you actually do in the experiment, right? What did you manipulate? What are your variables? Okay? So in this case, that would kind of be, your artifact group would kind of be that. That's what your variable was that you were manipulating. But you want to include that too. So some of this stuff, there's a lot of overlappingness between. You know, so you can kill several birds with one stone, so to speak, when you describe some of this stuff, because there's some sort of layering, overlapping that you can do. But I mean, what do you guys think? Is this all the information that you would like, that you would find helpful when you're reading stuff that people reported? Is there anything else that you guys would like to see when you read papers in terms of learning what were people looking for and hypothesizing in their studies?
Yes.
Yes? What else would you like?
I said this is pretty good.
This is pretty good?
Yeah.
Okay.
But I feel,
Yeah, hit me.
so I know this is ERP, EEG, that we're working
And behavior.
in the, before EEG, how would people still measure the behavioral output?
Okay, so that's a good question. So if anybody didn't hear what Love asked, she said before people used EEG to study memory, what would people use to get physiological measurements of memory? It's a really good question. Anybody have ideas? So let's say you got your time machine, like Marty McFly. You guys know who Marty McFly is?
Yeah.
Okay. You went back in time, and you went to some, what?
Good.
You went back in time to before we used EEG to study memory. What would you find people doing to capture physiology that might be related to memory?
Maybe just one of those, putting in the machine, well, let's see if they react to this.
Be a little bit more specific. Oh. Yes.
I'm just going by what was talked about in the book. EEG was kind of one of the first, and it was discovered in like the 1920s-ish.
By
so
who?
all, Hans Berger.
Yes.
And
Hansberg.
I was gonna say that, well, like before that, and this is gonna sound dumb, but all I'm thinking of is phrenology, which is not even a very good measure anyway. Like
Yeah. Well, the phrenology wouldn't
Yeah,
measure
that's-
physiology.
but like, yeah, that's all I'm thinking of, because I'm like, before then we didn't have fMRIs, we didn't have MRIs, we didn't have EEG. And EEG is kind of first.
Yeah.
First YouTube comment said first.
Not a whole lot. I mean, part of it's just a question of timing. You just asked, what could we do instead of ERPs? We could talk about MEG, we could talk about functional MRI, we could talk about lots of other, you know, I mean, you could do heart rate. You could see if you really want to get very simple, you could say, do people's heart rates increase when they're remembering or forgetting? Or when they're, when they're having a false alarm, a false memory. Some people are trying to make a lot of money with a company called No Lie MRI.
Really?
Yeah, lie detection. So, you might be interested to see, does someone's heart rate or respiration increase when they're making a false proclamation? Now, a false alarm isn't exactly a lie unless we know that they're doing it on purpose, right? Because you can't tell a lie if you don't know you're telling one. But other ways that are very rudimentary before EEG that can be done. Respiration, heart rate, pulse. Now, are they going to be very good and very useful? In my personal opinion, probably not very much. You might be able to pull something out though. You might be able to find something. You know, so you guys know that's what a polygraph is, right?
Yeah.
Yeah? A lie detector test. If you guys want to go try out, be an FBI agent or something like that, you got to take a polygraph test. That's what it is. It's just, it's all these physiological measurements. Your heart rate, your pulse, oh, how about GSR? Anybody know GSR? Galvanic skin response? You guys heard of that before in other classes? Like social psychology or something? What's galvanic skin response? A fancy way of saying it.
Sweat.
Sweat. Yeah. So, right? Let's say that you were, I don't know. You can decide if you want to be the guilty or the innocent person being examined on the stand, right? And or in the police office, and you have a polygraph being taken, right? Either way, you're probably going to be sweating a little bit, right? Whether you're innocent or guilty.
Sure.
But you can measure the changes in the relative degree and the timing of the sweat or whatever. So there's some other measures that you might be able to use. Yes, guys?
Oh, because what that was making me think of is in regards to our experiment, that might not help, just because one of the biggest flaws in polygraph is that, like you just said, if you don't know you're lying, it's not going to read it as you're lying.
Of course.
Like, or if you're just like a sociopath. But anyway, yeah, it's like it's not going to show up. So I guess in our experiment, like, probably wouldn't really do much.
No, and that's why we're not using it.
Yeah.
But those are just some ideas of other ways that you can do it. Okay, so how do you guys feel about our discussion about hypotheses? Was it pretty useful? Can I rely on you guys to integrate this into your papers? Okay. So a lot of you guys wrote pretty good starts for introductions, and then they kind of petered off right about the point when I was really getting excited about reading the hypotheses. I'm like, oh, this is really cool, really cool. What are they going to do? What are they interested in? What are they going to test? And they're like, oh, they didn't say. Darn it. Get really excited. Yes?
And like, because like we're talking about like, what our hypothesis is. What if the data kind of goes against what our hypothesis was?
That's okay.
Okay.
What happens if your hypothesis is wrong?
Then you
Say
still
it
prove
was-
something.
Huh?
You still prove something. Or not prove.
Yeah, I mean, what happens if your hypothesis is wrong?
Well, we don't do this.
Nothing. Your hypothesis is wrong. Same thing that happens if your hypothesis is right. It just means the hypothesis was right. In terms of a raw semantic level of like what happens, like all your job is as a scientist is to be objective. Now, none of us, raise your hand if you're a robot. Right? We might feel like robots sometimes, but we're not. Right? We're all human, which means that every single one of us, right, is not fully objective. We all have our biases. We all have our own opinions, perspectives, past experiences, things that are going to color the lens through which we see the world. Right? There's nothing wrong with that. It's okay. Whatever. I mean, so our job is to try to be objective in the science as much as we can. And whether or not a hypothesis turns out to be supported by the evidence or refuted by the evidence, right? All we want to do is just objectively say that. So whether it turns out to be right or wrong, it's okay. Our job is to say either one. And both, like you said, you've still shown something. Either way, it works out good. Now,